Hey guys, let's discuss new meta interview loop and round 9, which is called staff or architect round. Okay, so here the question is given to you is design Instagram reel recommendation system. So in Instagram we see that we get the reels, right, one by one. So you need to design recommendation engine for that, how it is taking all those reels and then showing you, right? So different user get different reels according to their browsing history and all, right? So expect here we will see answer based on two roles, E5 and E6. Okay, so E5 is senior software engineer, E4 also use the E5 answer. Okay, so E5 is senior software engineer and E5 is E6 is staff engineer. So E5 will say design a scalable recommendation pipeline with candidate generation, ranking and caching. What all things will be there? Candidate generation means your Instagram reels. Okay, that is called candidate here. And then ranking. So let's say he has combined, like he got 500 reels. Okay, now he will rank them, like which one will come first and then second, something like that. And then caching also. Okay, E6 staff engineer will more uh, tell about the features. Okay, so like for example, design Meta's global recommendation platform. So first one is embedding service. Okay, generate and serve user or content embeddings for personalized recommendation. So whatever you will have a recommendation, it will store that in a vector database, and in vector database we store embeddings, right, which is the number array, you can say. So it will convert that text into number or image into number. Okay, embeddings. Now online learning. So continuously update recommendation model using real-time user interaction. So today I like some let's say celebrity account. Okay, so he will then generate that feed from that celebrity's account also, right? So that is the online learning. Now based on the user interaction, real-time user interaction. Then feature stores. So centrally manage and serve online offline feature for model training and inference. Okay, so see, you will have one LLM model. Okay, initially it is blank, let's say it is blank. Then you will train that model on some data, right? And now when user request, let's say user is asking some question and he want that answer from the that model, he cannot directly go and give it request to that model. Okay, you will have one layer in between. Model inference system. Model inference system will load the model weights. Okay, so whatever model has we have trained will store, you can say that, as a weight of the model. Okay, so we load that weight in inference system. Okay, so it is like you have take that model only itself. Okay, so model is nothing but it's a weight, that's it. So and then model inference system will help us to means to connect that user request to this weights and then send response back to user. So what it is saying, centrally manage and serve online offline feature for model training and inference. Okay, so model training we have seen, inference we have seen, and online offline feature. So all the signals, like user click on what or how many time he has spent on some particular post, so all these things are called signals, and we store these signals into the so this one is called as feature. Okay, and we store that feature somewhere. So that is the online offline feature. Then GPU inference. So run recommendation model on GPU with low latency, high throughput serving. Okay, so model where we run the model, not the CPU but the GPU. Okay, and we'll see what is GPU inference here. Now AI observability next is, so he will take care AI observability also. Okay, who? E6 staff engineer, means when he will design a system. So monitor model latency, accuracy, drift, GPU usage and recommendation quality. Multi-region deployment is also important there. Deploy the platform across region for low latency, high availability and disaster recovery. Now what is GPU inference? Okay, so inference simply means using a trained AI model to make a prediction. We have seen that. Okay, you already have one trained AI model and you will use it to make the prediction. For example, user open Facebook, recommendation model looks at the user's interest, then model predict to which post or video the user is most likely to engage with. Okay, so instead of running this prediction on CPU, we use GPU because GPU can perform many mathematical operations in parallel. So GPU is powerful, that's why. Now, GPU inference means using GPUs to quickly run a trained recommendation model and generate prediction for user in real time. Okay, step one. So functional requirement, non-functional requirement. Functional requirement you will take from the interviewer. Okay, so let's say the functional requirement given to you is the system should recommend personalized reels. Okay, then support infinite scrolling. After that, learn from user interaction, recommend new creators, detect trending videos, support real-time personalization, and maintain feed freshness. Step 2 is non-functional requirements, so billions of user. Okay, your system should support billions of user, and this one is not for the thousand or lakhs of the user, billions of user, and millions of new video per day should get uploaded, downloaded. After that, recommendation latency should be less than 150 millisecond, high availability, highly scalable, cost efficient, and highly personalized. Okay, so if I will say, I would build a recommendation pipeline where candidate videos are retrieved based on the user interest. Okay, so ranked using ML model, cached for fast retrieval, and continuously update using the user interaction like watch time, likes, and shares. Now, high level architecture, if you see, so see, user request will go to API gateway. Okay, from here it will go to recommendation service, from here candidate generator, then ranking model, Redis cache, and then Reels feed. So we store that in Redis also. Okay, so that next time if user is coming, so we will directly fetch that reel from his cache. Now E6 will say at meta scale I would separate candidate generation. Okay, now he will separate all the services. Candidate generation is one service. Okay, then embedding services, feature store, and ranking model, online learning, AI observability, and distributed inference. So inference system could be very large, and it would be distributed, right? Distributed to multiple services, let's say. Now multiple servers, sorry. Then the system should continuously learn from user behavior while maintaining low latency across multiple regions. Okay, so now enterprise architecture, if you see here, so similar ditto, like this one only, just we have divided it into multiple services. Okay, so user request will go to API gateway. From there you will have different services like candidate service, embedding service, ranking service, feature store, trend detection, and advertisement service. Okay, from there this one will go to Redis. Okay, store that feed or reels, and then GPU inference, and then recommendation response. Now let's talk about few follow-up questions here. We will be talking about 13 follow-up questions, 13 to 14 follow-up questions here. So the first one is candidate generation. Okay, so if I will say retrieve a few thousands of relevant videos using user interest. Okay, so what all factors he will take, like user interest, where user is liking, sharing, okay, commenting, then followed creator, the creator who he has followed, and then trending videos and similar videos. Now E6 will say use multiple candidate sources. So for example, user history you will take. Okay, in user history your watch history, likes, search, or subscription will come. Okay, and then similar users, so find user with similar behavior or preferences. So I have like one video, let's say, and then another user also with the same age group, let's say, like that video. So the other accounts he has liked, he will recommend me that also, I might like that. Okay, so then trending videos, popular video based on views, likes, or shares. After that, new creators, and then recently uploaded videos. Okay, so all these candidate he will merge, he will send it to ML model, and then from there he will get the personalized recommendation. Okay, now each sources contribute candidate before ranking. Okay, then he will rank it and then send it to user. Now follow-up question 2 is ranking models. Okay, so ranking models, if I will say that rank candidate, okay, rank candidates using ML signals, ML signals like watch time, like, share, comment, or recency. Then E6 will say use a multi-stage ranking pipeline. Okay, so now your pipeline will have multiple stages. So first one is candidate retrieval, which will fetch a large set of relevant candidate using recall strategies. And then second is lightweight ranker. So lightweight ranker, what it will do, fast ranking using simple feature to filter top n candidate. Then he will do further ranking for those top end candidates which we got from this lightweight ranker. So deep neural ranker will come. Okay, so use deep learning model to score and rank top candidates accurately. Now then final ranking will happen. Okay, so he will apply business rules, he will diversify it. Freshness will also consider, okay, new videos and all. Duplicate to generate final rank. Deduplicate means it will remove the duplicate. Okay, so all these things. Then this improves both latency and recommendation quality. Then third follow-up question is user embeddings. Okay, so if I will say represent each user as an embedding capturing interest and behavior. So each user we will represent as embedding. Okay, we will convert its information into numbers, vector format. Okay, and store in vector db, and also we will capture his interest also and behavior also. Now E6 will say that generate embeddings from watch history, like, share, search history, follow graph, and device and language preferences. So embeddings are updated continuously. Okay. Follow-up question 4 is video embeddings. So video also you will store in a vector database. Okay. So for that also you will do embedding. So generate embeddings from caption. So in one video you will have a caption, you will have a hashtag, then you will have an audio, then you will have a video content. So you will generate embeddings for all. Okay, then E6 will say use multimodal embeddings combining. So like video frames, audio, OCR text. Okay, OCR text means inside image you have a text, so you will extract that text. And creator profile, engagement signals. So these embeddings improve semantic recommendations. Follow-up question 5 is cold and start user. Okay, cold start user, sorry. So cold start user means, see, if I will say that recommend trending reels, popular category, and location based content. Okay, E6 will say combine demographics, then device local, initial onboarding preferences, trending content, and exploration algorithm. So personalize quickly as interaction data become available. Interaction data. Okay, so when new user is coming, what you will show him? Okay, so you will show the trending reels, and then popular categories, and then location based content. So one regional, let's say in his region some video is popular, so you can show him that. Okay, so and then initially when you create account, so he asks you few questions, right, based on your hobby or something. So that is the interaction he does for to show you this kind of videos. Now follow-up question 6 is new creator. If new creator is coming, then if I will say reserve part of the feed for new creator. Okay, and E6 will say introduce an exploration strategy. Example 80% personalized and 20% exploration. So the balance engagement with creator discovery. So let's say I'm a new creator. Okay, so my video should also go to another user's feed, right? Otherwise, because initially though I will not have that many likes or something, right? So 20% he will capacity he will take aside for these kind of videos. So he will show the new creator video, and if people like it, then it will start gaining the followers. Okay, now follow-up question 7. So this diversity. Okay, so avoid showing similar videos repeatedly. So you can diversify using categories, language, creator, content type, and topics. So apply diversity after ranking. Now follow-up question 8 is freshness. So new videos also important, right? So boost recently uploaded videos. So E6 will balance fresh uploads, historical engagement, and trending content. So use freshness decay function in ranking. Now follow-up question 9 is trend detection. Okay, so it will detect the trend, what is going on. So if I will say that monitor rapidly increasing engagement, and E6 will show us some pipelines. So see, first he will find the trend based on the views, number of views, then likes, share, and growth rate of the video also, and trending score. Okay, he will get the trending score. So trending score are recomputed continuously using streaming data. So continuously we just recompute this trending score, and based on this score we will show the video to the user. Follow-up question 10 is real-time personalization. So update recommendation immediately after user interaction. So let's say I like one account, and then I will see post immediately from that account. So user event would be something like this. Let's say watch event happen. Okay, we will store that in a Kafka. From Kafka it will go to feature store. Okay, and then ranking service, and then it will update the feed. So recommendation evolve within seconds. Okay, it should not take much time. All these things should be completed within a second. follow-up question 11 is feature store. So where you are storing all this feature. Let's say I like one product. Okay, so this is the recommendation for recommendation input for the recommendation engine, right? Like I like this product, so he will recommend me similar kind of product, okay, or the variety of that product. So where he will store all this information. So first of all, this information is called the feature. Okay, so thousands of let's say click events or something. So these are called feature, and we store that feature in a feature store, and from there this data will go to ML, okay, machine learning model. So if I will say store reusable ML feature for training and inference, okay, so reusable ML feature, okay, so you can reuse, so you store that kind of feature. E6 will say maintain this ensures feature consistency. So online feature and offline feature store, okay, two things you have. So online feature store, real-time inference will go there, and offline feature store model training we use generally. Now follow-up question 12 is online learning. Okay, so if I will say continuously update model using recent user interaction, and E6 will say support incremental model update, streaming feature update, online reinforcement, and continuous retraining. Okay. So what is incremental model update? Incremental model update the model with new data without retraining it from scratch. Okay, and then streaming feature update, so continuously update user feature as new activity happen in the real time. And what is online reinforcement learning? Continuously improve recommendation based on user feedback and actions. Okay, and then continuous retraining pipeline, so automatically retrain the model regularly using the latest data. Now follow-up question 13 is multi-region inference. Okay, so if I will say deploy recommendation service close to user, so in multiple region you will deploy, but you will deploy it close to user, and then E6 will say run the AI model to the nearest region to the user for the fast response while automatically copying updated model and feature to other region in the background. Okay, so you need to make a duplicate copy also in the other region. So for example, in Indian user, so India inference server he will use for the faster response, and meanwhile update model or feature are replicated to US and Europe etc. So that's it. Thank you.